Dr. Sanjay K. Sharma to this August gathering. Sir started his illustrious career with a PhD in synthetic organophosphorus chemistry and computational chemistry from the prestigious University of Rajasthan. His research expertise includes organic chemistry, green chemistry, heavy metal removal, biopolymers, and green corrosion inhibition. He has, to his credit, authored over 100 research papers in high impact journals of international repute and contributed 20 books from internationally acclaimed publication houses. In his current role as series editor of Springer for the book series Green Chemistry for Sustainability, he has been involved in editing 39 different titles of various international contributors so far. Sir is a member of several professional societies. To name a few, Fellow of Royal Society of Chemistry, Member of American Chemical Society, Fellow of Indian Council of Chemists, Fellow of Indian Chemical Society. Dr. Sharma is also associated as an editorial board member or reviewer for more than 20 international journals, including the prestigious Green Chemistry, Ultrasonics, Green Chemistry Letters and Reviews, and Ultrasonic Sonochemistry. Dr. Sharma is also serving as editor in chief for Rasayan Journal of Chemistry, a Scopus Elsevier Index journal. Sir, in his capacity as a resource person, has delivered lectures for various prestigious national and international organizations on green chemistry, water sustainability, and manuscript writing. Presently, Dr. Sharma holds the position of Professor of Chemistry and Associate Dean Research, JECRC University, Jaipur. His research papers are internationally acclaimed with 1,800 citations, an H index of 23, and ITIN index of 31. Sir has more than 18 years of teaching experience at graduate and postgraduate level. Sir's bio note is quite rich and to highlight all the credentials within the time frame of this seminar is highly challenging. With these few words, I would like to state that we are indeed honored to listen to such an illustrious researcher, and we are looking forward to your lecture on one of the most relevant topics for today's global village, green chemistry for environmental sustainability. Over to you, sir.
Thank you, Dr. Pratibha.
Thank you very much, ma'am. Thank you very much for this kind introduction. Thank you.
Dr. Sharda, are we having few words from Dr. Sharma? Is our dean joining us?
Okay, ma'am. Sure.
Is our dean with us?
Dean ma'am is join?
No, she is. I'm just asking you, has she joined?
No, not yet.
Fine. Then we'd like to have few words from Dr. Sharma before we start his session. Yes.
Yes. Dr. Sharma?
Okay. First of all, I must thank the organizers and the authorities of Avinash Link University for inviting me and for organizing this wonderful webinar. Actually, this pandemic, COVID-19 pandemic, is very critical situation for all of us. And in every talk of mine, I always highlight a positive point of this pandemic 19 is that we all are now able to connect with each other through technology. It was not before. Earlier we were not able to connect, or we were negligent. We were not aware about the using such technologies for sharing the knowledge. But during this period, even we are struggling for the vaccine or the medicine of this virus, but still this one positive thing I have observed, that people came closer technically. The networking is enhancing. The people are more close. They are sharing knowledge, they are sharing experiences, and through such webinars or through such sessions, students of far remote places are able to connect with the people of their field, the active researchers of their field, the professors of different universities. So it is a good thing. So first of all, we should take it positively in this aspect, that due to this situation we are now connected through technology and sharing the knowledge. Even I pray to God, to Almighty, to save all of us, to finish this crisis, and so that things should be normal. Now come to the point, come to the theme of this talk. Actually, the title of the talk is Green Chemistry for Environmental Sustainability. When we talk about environment and when we talk about sustainability, these two things are not different things. These two things are actually one. They complement each other and they are one. If we save environment, we save sustainability. If we serve sustainability, we save environment. So these two things, when come together, and when we talk about its sustainability, means environmental sustainability, then few things come in my mind. I hope the students, young students who are listening through this webinar and who are enthusiastic and who are studying chemistry or doing chemistry at undergraduate level, postgraduate level, or even PhD. I hope many PhD scholars are also there connected with us. For them also, it should be very clear that whenever we practice chemistry, maybe it is organic chemistry, maybe it is inorganic chemistry, maybe it is physical chemistry, analytical chemistry, computational chemistry, right? In each and every stream of chemistry, if we focus on the practices of producing less waste, consuming less energy, consuming less efforts, consuming less chemicals, then that chemistry is green chemistry. Simple. Green chemistry is nothing new. It is not a big deal, but it is a philosophy. It is a actually a practice. How you practice your chemistry? If you are practicing in a greener way, if you are practice in an energy efficient way, then it would become green. So before we start formally, I would like to share my screen. Can I share from here? In window.
Yes, sir. Dr. Sharada, if you stop presenting.
Ma'am, please you stop sharing. Yeah, thank you, thank you. Now, from here it can be shared. Yes. So, just a minute. Now, yeah, is it visible? Is it visible?
Yes, sir.
Is it visible to all?
Yes, please, participants, yes, sir. Yes, sir, possible.
Okay,
Yes.
okay. So, I would like to share my experience as a man just introduced me. I started my career as an organic chemist, and then I shifted from organic chemistry to green chemistry. And I contributed my first book from CRC Television Francis, and the title of that book was Green Chemistry for Environmental Sustainability. So this title is very close to my heart, so that I would love to discuss this topic. I can talk on this topic for hours. So let us start. Actually, what is the need of such session? What is the need of organizing this webinar on green chemistry? Why your head of department bothered to organize this conference, this webinar? Because we all are suffering from some diseases. We are all are suffering from some challenges like industrial pollution, like carbon emission. Just a minute. Carbon emission, industrial waste, global warming. There are a lot of negative impacts of global warming. We can discuss it later on. Drought, water crisis. My dear friends, this photograph is a real photograph of Jaipur city, from where I am talking. This is the real photograph. In every summer, these scenes, such photographs are very common. So we are facing drinking water challenge. 9,640 rural schools are having no drinking water. 30% water resources just we have. This type of scenes are very common. People are, fighting for the water. So these are the challenges which we are facing, our generation is facing, our youngsters is facing. And whatever water is available, it is toxic, it is having heavy metals, it is having contaminations, water pollution is everywhere, tsunami is another challenge. All these challenges, they challenge which is called climate change. Everyone nowadays talking about climate change, and climate change is the big threat for the world. I request all the participants, kindly mute your mic, please. All the participants, please mute your mics. Okay, so the possible risk of climate change is ecosystem change, flooding of coastal communities, spread of diseases, increase of extreme weather events, and all these. Means these are the issues which the globe, which the whole world is facing. Enhanced global warming, depletion of resources, food shortage, shortage of potable water, housing, waste, all these challenges. And now the question is, how can chemistry contribute in the solution? How can a chemist, because my dear students, you all are practicing chemistry right now, and very soon you will serve the society. And I must congratulate you that you are studying in a very good institution. I have visited this university personally, and I am very much impressed with the teaching faculty, teaching atmosphere, the work culture, and the study culture in your university. It is quite amazing. Means I must congratulate you all that you are not only studying there, you are becoming a good citizen there. So whenever you go to the society to serve the society as a chemist, you will ask yourself, how can you contribute to the society? And then the solution comes in green chemistry. Green chemistry is a solution which is preventing pollution and sustaining the earth. So how it came in the existence, that we will discuss. But before that, one very obvious question I am sure is blinking in everybody's mind. Every student who is connecting right now, this question is in everybody's mind, that is environmental chemistry same as green chemistry? It is an obvious question, because in our teaching system, in our teaching pedagogy at school level and then college level and then university level, suddenly someday we should start studying green chemistry. But till then, we are not aware about green chemistry. And the most close word to the green chemistry which we know is environmental chemistry only. So it is very obvious question that is environmental chemistry same as green chemistry? So the answer is no, a big no. What is the difference? When we talk about environmental chemistry is chemistry of the environment. Chemistry of the environment that explains nature and the impact of man on the nature. While green chemistry is chemistry for the environment, that is more environmental friendly chemistry. That's why I told you earlier that whether you are organic chemistry, whether you are practicing organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry, whatever chemistry you are following, if you are following environmental friendly concepts, environmentally friendly processing, then your chemistry will be for the environment and will be called as green chemistry. So there is a very clear-cut difference between environmental chemistry and green chemistry. Environmental chemistry is of the environment and green chemistry is for the environment. Okay, this stream was invented in 1998 by the brilliant duo Professor Paul Anastas and John Warner, and these two brilliant scientists invented green chemistry. And the definition, the official definition of green chemistry is, it may be defined as invention, design, and application of chemical products and processes to reduce or to eliminate the use and generation of hazardous substances. Now, we all are talking about environmental sustainability issues. Everybody is talking about environmental sustainability issues. But how it comes? How it comes in the existence? Actually, in any process or any manufacturing unit or in any synthetic process, these are the steps which normally any process contains: heating, cooling, stirring, distillation, compression, pumping, separation, etc., etc., etc. These steps require energy, and for energy we burn fossil fuels. When we burn fossil fuels eliminate carbon dioxide to atmosphere, and carbon dioxide creates global warming and creates climate change. And due to global warming and climate change, all environmental sustainability issues come in the existence. Means this is a cycle, and this cycle we follow in each and every synthetic method or manufacturing method. Now, what option we have? We have two options. Either we stop development, we stop industrialization, we stop technical advancement. So when we stop technical advancement, we need not to heat, cool, stir, distill or other steps, but it is not possible. Then what is the alternate? So the second alternate is we should follow the environmental friendly processes, because when we opt environmental friendly processes, we reduce our energy requirements, and when we reduce our energy requirements, definitely we contribute in decreasing the carbon dioxide level in the atmosphere. And when we able to decrease the carbon dioxide level in the atmosphere, the global warming and climate change will be reduced, and so that we can contribute for the sustainability of environment. Now, on the other hand, what we do? We do the exploitation of our natural resources. We overconsume our natural resources, and we practice deforestation. When we practice these three problems give another three problems, which are population explosion, urbanization, industrialization. And when these three next problem arise, there are few consequences, and for those consequences there are few needs. So consequences are urban degradation, greenhouse gases, global warming, ozone depletion, extinction of wildlife. And when these consequences are there, we need some other things. We need clean environment, we need pollution prevention, waste minimization, eco-efficiency, health and safety. Now, my dear friends, when we have to serve consequences as well as needs, when we have to serve both of these at the same time, the solution is green chemistry. And green chemistry is a set of 12 principles which we will discuss later on. So it is also known as sustainable chemistry, which enable chemists to create safe, energy efficient and non-toxic chemical products and processes without harming human health and the environment. Now everyone knows that green chemistry works towards sustainability by making chemical products that do not harm, by using industrial processes that reduce or eliminate hazardous chemicals, by designing more efficient processes that minimize the production of waste, by preventing pollution before it happens, by saving companies money by using less energy and fewer, safer chemicals, thus reducing the costs of pollution control and waste disposal. But green chemistry is more than that. Such practices which are not very common, which people do not know, which students are not aware about. So before that, I just want to share with you my contribution as an author, editor and researcher so far. I have started authoring the book with Green Chemistry for Environmental Sustainability from CRC Taylor and Francis. Another book on polymer from Royal Society of Chemistry. One more book from Royal Society of Chemistry on heavy metals in water. One more book on ultrasound. Another book on green corrosion chemistry and engineering. Another book from Springer, Advances in Water Treatment. One more book, Biosurfactants from CRC and Taylor Francis. One more book, Water Reuse and Management. All these books, if you see, all are focusing green chemistry practices. Ultrasound, biosurfactant, green corrosion chemistry, biopolymer, all these things are related with green chemistry. One more book on green chemistry for dyes removal from Wiley. Another book recently published in 2020, Bioremediation from CRC Taylor and Francis. And one more book from CRC Taylor and Francis on green chemistry in scientific literature. And this is the book which is going to be released in 2020 from elsewhere, again on green chemistry. And the title is Green Chemistry and Water Remediation. Why I am sharing all this with you? I am sharing all this with you because there is a lot of things have been published so far in the area of green chemistry. And unfortunately, still most of our students are not aware. Most of our students are not, educated about green chemistry and use of its principles. It has 12 principles. And if we summarize these 12, you just read fastly that these 12 are preventing waste, maximum atom economy, less hazardous chemicals, safer solvents, increase energy efficiency, use renewable feedstock, avoid chemical derivatives, use catalysts, design chemicals and produce to degrade after use, analyze in real time and minimize potential of accidents. So these 12 principles, and all these 12 principles are talking about reducing waste, reducing material, reducing hazard, reducing risk, reducing energy, reducing environmental impact, and obviously reducing the cost. So green chemistry is all about reducing all these things. And if, my dear friends, if a technique is helping you to reduce waste, reduce material, reduce hazard, risk, energy, environmental impact, and cost, then it would be obviously a greener practice. So 12 principles, as we just seen, prevention. Prevention means it is better to prevent waste than to treat or to clean up waste after it has been created. Less hazardous chemical synthesis, designing safer chemicals, atom economy. Atom economy is a very wonderful principle. Actually, all 12 principles, if we talk for all 12 in length, it would be very lengthy lecture. So I will emphasize on the important things which I want to share with you and which will be immediately useful for you. And later on, if you are interested, you can explore many more things around those points. So atom economy is one of the best principle of green chemistry. My dear friends, so far we are learning chemistry in the terms of percentage yield. For any organic reaction, for any synthetic reaction, we are habitual to study it in terms of percentage yield. But we never calculate the percentage atom economy. How many percent of atoms have been utilized in a reaction? That is important than the percentage yield. That I will discuss you with an example in following slides. Fifth, safer solvent and auxiliaries, because solvents have a very important role in synthetic chemistry. And if the synthetic chemistry, if we are using organic solvents, all those solvents are very hazardous and costly. So use safer solvent and auxiliary we must use. Design for energy efficiency. It is quite obvious by the title that energy consumption should be reduced. Use renewable feedstock means we should use such feedstock, we should use such raw material which can be reused, because it would be beneficial for our technical as well as economical aspects. Reduce derivatives, it is another very important principle, especially in the synthetic organic chemistry. If we are producing one compound by going through 3-4 steps, so we are unnecessarily producing some derivatives to get final product. So producing derivatives means wastage of chemicals, wastage of time, wastage of resources. So we should reduce derivatives, we should reduce steps in a reaction. That is also very important if we want to serve our environment, if we want to reduce the energy functions. Catalysis is another wonderful principle, because we know that using catalyst may increase the rate of reaction, and in many cases there are selective catalysts are available nowadays which can be used for better yield, for better feasibility, and for better reaction mechanism. So we should use catalysts. Then 10th, design for degradation. Chemical products should be designed so that at the end of their function, they break down into innocuous degradation products and do not persist in the environment. It is important in the case of research where polymers are involved, or where the chemicals which are not degradable are involved. So when we practice research, we should practice in such a way that the products or the byproducts or the derivatives must be degradable. Real-time analysis, it is another very important principle. Analytical methodologies need to be further developed to allow for real time. Actually, how it happens? We are habitual to test every compound after its production. We characterize it through spectroscopy, we characterize it through with other many technologies. But if we start analyzing it at real time means in the reaction mixture only, we can use our time very intelligently, and we can minimize energy consumption, because if at real time we can characterize a compound, it would be easier for us to proceed further than design for degradation, real-time analysis, this we are. Then 12th is inherently safer chemistry for accident prevention. It is another a safety measure. We should use the substances and the form of a substance used in chemical process should be chosen to minimize the potential for chemical accidents, including releases, explosions, and fires. So these are 12 principles in journal. You can Google it, you can search it, and you can see these principles in detail. Now, how education is related with green chemistry? As we all know, and I'm sure the vision of your university, your organization is also the same, that education is a systematic execution of awareness. And everybody, every teacher is doing the same. Through this webinar also we are educating you all. And this webinar is a platform of making awareness. So education is a systematic execution of awareness. And Terry Collins, Professor Terry Collins, who is a great legendary green chemist, he once said that chemistry has an important role to play in achieving a sustainable civilization on the earth. And he is quite right. If we see that where the green chemistry is involved now during the COVID-19 pandemic, we all are waiting for the vaccine, we all are waiting for the treatment, we all are waiting for the medicine. So if we connect how green chemistry is useful in pharmaceutical studies, so it is quite obvious that pharmaceutical studies is also based on chemistry. Pharmaceutical chemistry, organic chemistry, these are involved in preparation of the pharmaceutical drugs. Analytical chemistry involves the quality control and analysis of the pharmaceuticals. So, therefore, the principles of chemistry are also applicable to the pharmacy education and research as well. It means pharmaceutical study is not different from chemistry, but it is based on chemistry, so that the principles of chemistry are equally applicable for pharmaceutical education and research. And the pharmaceutical industry is the most dynamic part of the chemical industry. If you say today, in today's time, we all are dependent on the pharmaceutical industry. The mankind, the whole world is fighting with coronavirus, and we all are waiting for a medicine. We pray 24/7 that our pharmaceutical researchers, please, they will be successful and give some solution of this problem. So it is in the forefront of the big changes towards greener feedstock, safer solvents, alternative processes, and innovative ideas. All these changes will be increase the environmental credentials of the pharmaceutical industry, but at the same time will cut down cost and materials for the manufacturing operations. Now, if you see, the pharmaceutical industry strives to keep in the forefront of the manufacturers which apply most of the green innovations and makes its products safer for workers and consumers. Manufacturers are aware of the facts and take very seriously the environmental problems. It is hoped that future changes into greener methods less toxic reagents and solvents, and minimizing effluents and solid waste might alter the extent of the problem. Also, drug recycling and reduction of waste from households is considered very important. Now, if we check what principles, which principles are important for principles which we will discuss in detail and which are the most important for all the chemists. One is maximize atom economy, second use of safer solvents, and third use of catalysts. So my dear friends, especially the students of post-graduation and the scholars, PhD students, you please note it down that these three principles are the most useful principle. They are going to be most useful principle in your professional life if you are going to opt a career as a chemist. So if we talk about green chemistry, it means avoiding waste, environmental friendly, energy efficient, safe, sustainable, atom efficient, non-toxic, catalytic, and whatnot. And when all these things we practice in the pharmaceutical study, it becomes pharmaceutical green chemistry. Because pharmaceutical industry is based on safety, reliability, economy, and efficiency. Right? And when these four pillars mix with green chemistry principles, a new stream comes in existence which is called pharmaceutical green chemistry. Now see this development timeline. For any drug or for any vaccine, this is the pharmaceutical development timeline, which starts from drug discovery and which ends on ongoing research and monitoring. If we see from end to end, so you will observe that drug discovery, then preclinical, then phase 1, then phase 2, then phase 3, clinical trials, then FDA review, then scale up, and then ongoing research and monitoring. So my dear friends, during this timeline, at every step, we can reduce our energy consumptions. We can reduce the involvement of hazardous substances. We can reduce the intervention of or involving of other hazardous auxiliaries. And if we do so, we definitely making our process greener. So green chemistry starts from the first point, from this drug discovery to the last point, means ongoing research and monitoring. Now we talk about atom economy. Atom economy is the game changer. Believe me, it is a game changer. Because an atom is a terrible thing to waste. Now, I will discuss with you an example. This is an example, a very simple example in which butanol is reacting with sodium bromide and sulfuric acid, and butyl bromide is forming. So you all please see this reaction, and you will observe that there are few atoms are green colored and few are red colored. Green colored atoms are the atoms which are utilized, and the red color atoms which are unutilized. Now make a table in which you can calculate the reagent formula weights, then utilized atom, then weight of utilized atom, then unutilized atom, and weight of unutilized atom. And after doing so, we apply a formula. The formula of percentage atom economy is equal to formula weight of atoms utilized divided by formula weight of all reactants into 100. And in this particular case, you will find that atom economy is 50%. 137 by 275 into 100. And by this calculation, this reaction is not a promising reaction, not very green reaction. My dear friends, when percentage atom economy of any reaction is more than 60% or 70% and so, then it would be called a green reaction, a green process. So, it's my humble request to all the authorities, to all the professors, to all the teachers to please make aware your students about atom economy rather than percentage yield. Percentage yield is not useful term. The percentage atom economy is more useful, more mathematical and more practical term. And through this term, we are able to know how many atoms are utilizing and producing the desired product and how many atoms are just unutilized and producing waste. So it would be very clear. Now, pharmaceutical industry and the use of solvents. Pharmaceutical industries are known for the use large of amounts of solvents. Solvents used consistently accounts for between 80 to 90%. Moreover, within these operations, solvents play a dominant role in the overall toxicity profile. Green chemistry enough emphasis on solvent use and a case for greater awareness of solvent issues in batch chemical operations, typically found in the pharmaceutical industries. These are the solvents, and we can practice it in our daily life, in our daily routine chemistry. It doesn't matter whether you are practicing in pharmaceutical industry or not, but this is a table of the solvents, and the table was given by Dunn and Perry et al., published in Green Chemistry in 2008. These are the undesirable solvents: pentane, hexane, diisopropyl ether, diethyl ether, dichloromethane. All red colored solvents are undesirable. All blue color solvents are usable. Usable. I underline the word usable. But the all green colored solvents are preferred. Its alternate is water. Hexane, its alternate is acetone. Diisopropyl ether, its alternate is ethanol. So these are the better options. These are the better solvents. Another comparison, another alternative available. If we are using pentane, we can use heptane in place of it. If you are hexane, we can use heptane in place of it. So, by using alternative solvents, we can reduce, we can minimize the production of waste. We can minimize the consumption of solvents, consumption of other chemicals. Now, another very important term is E factor. I am sure many of you are not aware about E factor. What is E factor? The pharmaceutical industry has initiated many studies on the replacement of toxic solvents with solvents that are benign to human health. And the E factor is a simple metric of green chemistry which can measure the efficiency of an industry concerning solvents and waste. This term was defined by Roger Sheldon. So the E factor calculation is defined by the ratio of the mass of waste per unit of the product. This is the formula: total waste by product. So E factor is also very important term which can be calculated for making a process successful. Now, the next thing is use of catalyst. Use of catalyst is new catalytic synthetic methods in organic chemistry that are satisfy increasingly stringent environmental constraints and in great demand of the pharmaceutical and chemical industries. In addition, novel catalytic procedures are necessary to produce the emerging classes of organic compounds that are becoming the targets of molecular and biomedical research. As I told you earlier, that by using catalysts we can enhance the reaction rate, we can enhance the percentage yield, we can enhance the chances of making a reaction successful. So in that continuation, enzyme catalyzed chemical transformations are now widely recognized as practical alternatives to traditional non-biological organic synthesis and as convenient solution to certain intractable synthetic problems. Biocatalysis is one of them. Biocatalysis has become a central issue of green chemistry, and the application in chemical manufacturing can become very promising. Enzymes can accelerate a reaction, lower the use of energy, use alternative starting materials, reduce the use of solvents and the production of waste. Enzymes are actually very useful. Enzymes are biomaterials that can biodegrade under environmental conditions. They are considered alternative and renewable chemicals, and their cost is very low for application in the pharmaceutical industries. The enzymes have the advantage to cut down the number of steps in an organic reaction and can produce clean products with no need of purification. It is a merit. It is the merit of using enzymes as catalyst. I am repeating, the enzymes have the advantage to cut down the number of steps in an organic reaction. Cut down the steps means less derivatives will be formed, means following a green chemistry principle in an organic reaction, and can produce clean products with no need of purification. Now, my dear friends, we are taking an example of synthesis of ibuprofen. Ibuprofen is a drug. It is an anti-inflammatory drug. And ibuprofen can be synthesized by two methods. One is Boot synthesis and another one is green synthesis. First of all, see how it produces through Boot synthesis. This is the Boot synthesis reaction. You please see it very carefully. In this Boot synthesis reaction, because it is all about Friedel-Crafts acetylation of isobutyl benzene, so the reaction is actually acetylation of isobutyl benzene, and 1, 2, 3, 4, 5, 6. This Boot synthesis involves 6 steps. 6 steps means there are 5 derivatives are formed in between. Got it? So remember it, in this process, the process is involving 6 steps and producing 5 intermediate 5 derivatives in between, right? And this red color, you can see these red color things, these are the wastes. These wastes are formed. Now see the green synthesis of the same product. In this green synthesis, you will observe only 3 steps are involved and only 1 waste is produced, and which is also actually not a waste. It is not a waste. So when we compare Boot synthesis versus green synthesis, so there are clear-cut differences. Number 1, in Boot synthesis, aluminium trichloride is not a true catalyst, which is only hydrated and has to be disposed as a waste byproduct, which has to be landfilled. In green synthesis, hydrogen fluoride is a true catalyst, which can be recovered and reused with over 99.9% efficiency. HCl, C2H2COH, acetic acid, NH3 and AI are the waste. which needs to be treated or disposed. On the other hand, there is only acetic acid as the only waste and no need of cleanup. Third difference, it involves 6 steps, required more energy. On the other hand, it involves 3 steps only, fewer energy, fewer steps, expenditure on energy is reduced. And fourth, last and the most important, that the percentage atom economy of boot synthesis is just 40%. It means it is a very poor performance of boot synthesis, while the green synthesis has the atom economy of 77%. And moreover, unnecessary derivatives are eliminated and catalysts can be recovered and reused repeatedly. It means green synthesis is better than boot synthesis. And dear students, you can see very clearly that the atom economy, percentage atom economy of green synthesis is 77%, which is quite higher than that of boot synthesis, which has only 40%. So now the question is, has green chemistry a significant impact in the pharmaceutical industry? Today, I focus the lecture on pharmaceutical industry because this is the time when we all are looking towards the pharmaceutical industry only, because that industry is only industry which can save the mankind, which can save us all. So I am trying to focus that using green chemistry principles make pharmaceutical industries more powerful, more visionary, and more productive. So the new methods of green chemistry have positive results in the pharmaceutical industry because their R&D investment is very robust and can cover research expenses and support innovative ideas. By applying green chemistry methods, the pharmaceutical industries have better efficiency and lower cost for their operations, lower solvent use, less waste, and improvement in the green credentials of the industry. Scientists believe that green chemistry is going to transform the pharmaceutical industry and drug manufacturing in the future. Now come to the point, green chemistry education. This is very important. I'm not aware that in your university green chemistry is in their curriculum or not, but in most universities around the world have agreed to incorporate green chemistry into their curriculum. Various chemical societies have recognized green chemistry as a core research area for their journal. Royal Society of Chemistry even has a journal named Green Chemistry exclusively to cover research in this area. Availability of educational resources. There are lot of educational resources are available online, but the problem is we are not aware about them. We are not, nobody has asked ever that you go to the Google, you search the resources of green chemistry and start learning. Though such resources are becoming more abundant and readily available for undergraduates, graduates, and researchers, students and teachers, maybe many times teachers also are not aware about it. I am going to share some of the important and world-renowned resources of the green chemistry. One is Warner Babcock Institute of Green Chemistry, which is founded by none other than John C. Warner, who invented green chemistry. Another platform is Beyond Benign. It is also headed by John C. Warner. You can go to their website. Beyond Benign website is very, very good website and very good resource for green chemistry content. So a website managed by the non-profit organization Beyond Benign, which aims to revamp the teaching of chemistry so that students would connect in a better way with the world and be able to relate chemistry to human health and the environment. Royal Society of Chemistry, it is very well known, highly reputed professional society, and Royal Society of Chemistry is running chapters in several countries around the world. In India, at Delhi University, a chapter is running successfully. Royal Society of Chemistry is also publishing a book series, Royal's RSC Green Chemistry series, and I'm thankful to them that I have also contributed one book in this series. So I'm thankful to Royal Society of Chemistry. Green Chemistry Network UK, it is another a very good resource of green chemistry content, and you can go to its website and see the contents. This network was established by Professor James Clark, and James Clark is the person who initiated the journal Green Chemistry, the first journal of green chemistry area. American Chemical Society jointly entered with US Environmental Protection Agency in 1998 to support and spread the awareness about green chemistry. A book, Real World Cases in Green Chemistry, published in 2000, in which real cases were presented in a comprehensive manner. I request the head of department and the professor in charge through this webinar that if it is not available, you please order two important books in your library. One is Green Chemistry, Theory and Practices by Anastas and Warner, and second book is Real World Cases in Green Chemistry, published from American Chemical Society. These two books are very important books. These two books are, eye-opener actually. And I suggest every student who is willing to practice, who is willing to pursue his career in the field of green chemistry, he or she must have these two books. One is Green Chemistry, Theory and Practices, and another book is Real World Cases in Green Chemistry. American Chemical Society is very much involved with the promotional and educational activities related to green chemistry. Then IUPAC, International Union of Pure and Applied Chemistry. This platform is dedicated to chemistry and chemistry-related advancement. It is a professionally working non-government society which is closely involved in the chemistry world by conducting chapters in many countries, including Australia, Brazil, China, India, Japan, etc. IUPAC is working on the front of green chemistry since 1996. The year of establishment of Working Party on Synthetic Pathways and Processes on Green Chemistry. Now, what about green chemistry in India? What is the scenario? So, Green Chemistry Network Center was established under the recommendation of Paul T. Anastas in year 1999. A national symposium on green chemistry was organized for the first time by the Department of Chemistry. There are another methods through which students and teachers can get more involved in green chemistry. These include participation of students in outreach activities by the Green Chemistry Institutes. So from where to start? Actually, the training of trainers and education of educators is the first step. We must educate our teachers first. We must train our teacher first. So the success of green chemistry depends on training of trainers and education of educators. Awareness workshops should be organized at college and university level. Future challenges of green chemistry education. It can only make significant progress once it is diffused in all areas of chemistry in order to reach all chemists and pharmacists. As I told you earlier, it doesn't matter that you are inorganic chemist or organic chemist or physical chemist. It doesn't matter. If you are following the principles of green chemistry, you are a green chemist, right? So it can only make significant progress once it is diffused in all areas of chemistry. This process can only be achieved by integrating the principles of green chemistry in all levels of education, starting from the school level. Some challenges are also there. Systematic recognition of hazard toxicity as a physical chemical property of molecular structure that can be designed and manipulated. Development and utilization of practical laboratory experiments. It is another challenge. Balance equation in organic textbook and replacement of yield with atom economy. It is the biggest challenge, because as of now, in every textbook, at every level of education, we are studying only percentage yield. So balancing equation in organic textbooks and replacement of yield with atom economy, it is a big challenge. Introduction of the basic concepts of chemical toxicology and the molecular basis of hazard. Incorporation of green chemistry topics on professional certification examinations, and teacher reference materials for incorporating green chemistry into existing courses. So these are some challenges. What we expect from government? Actually, it is fact, and it is a requirement as well, that adopting and practicing of green chemistry more so in the developing countries like India is a must necessity rather than an alternating approach, because we are the very populated country, very big country. So for our green chemistry is not an option. It is not an alternating approach. Green chemistry is a must necessity. So government should realize the seriousness of the damaging environment due to industrialization and should implement strict rules and laws against it. And most importantly, government should also take constructive steps by announcing promotional schemes for researchers, students, entrepreneurs, which will make them motivated to adopt the philosophy of green chemistry more and more in their practice. So what opportunities are available? All these initiatives have wonderful opportunities inbuilt. We just have to explore them and equip ourselves accordingly. We should use available resources skillfully and prepare ourselves for the challenges ahead. These are few important links which a student can take a screenshot or can note down. These are important and useful resources for green chemistry education. Now, concluding remark. Scientists believe that green chemistry is going to transform the chemistry industry, pharmaceutical industry, and drug manufacturing in the future. Green chemistry can deliver both environmental and economic benefit, and the pharmaceutical industry is keen to adopt most of its principles. Although green chemistry philosophy has been generally accepted by the scientific community, technical green chemistry evolution through education and investment has yet to achieve the appropriate attention and effort. This I have already shared. At last, the success of green chemistry depends on training of trainers and education of educators is the only option to make the coming generation of chemists comfortable with green chemistry. It has been said that the revolution of one day becomes the new orthodoxy of the next when the 12 principles of green chemistry are simply incorporated as an integral part of everyday chemistry. There will no longer be a need for the focusing and highlighting green chemistry. And when that day comes, the challenges that chemistry will meet cannot be imagined. At last, I conclude my talk with the wisdom words of Shri Gurudev Ravi Shankar. When you care for nature, be assured that nature cares for you more than a mother would do for her child. My dear friends, this nature is our mother. When we care of our mother, the mother will care all of us. Thank you very much. And I again want to thank all the organizers of this webinar and the participants who listened this webinar patiently. Thank you very much. These are my contact details. Apart from these, you can see my YouTube channel, which is named Professor Sanjay K. Sharma. You can subscribe it for the updates. Thank you very much.
That was an excellent presentation, Dr. Sharma.
Thank you, madam. Thank you very much, ma'am.
Now I invite.
Any question if anybody want to ask? We can take one or two questions.
Participants,
Good evening, sir.
Any question? Any participant?
yeah,
It is wonderful. There are 143 participants right now.
yeah.
I must congratulate the professor and head of department to organize this wonderful webinar. Any question? Yes, I am seeing some chats also.
Kirtana, you want to ask something? Yeah.
Can you ask questions or also drop in the chat box your questions? Participants, yes, students.
And apart, and I want to share with the participants, the students. Apart from this webinar, you can ask me anytime. You can mail me, you can message me, you can call me. I am available 24/7.
Thank you, sir.
So no question right now.
Somebody started talking.
Yeah, stop. Kirtana, I think Kirtana started.
Ma'am, can you hear me, ma'am?
Yes, Kirtana, go ahead.
Good evening, sir.
Good evening.
Sir, do all pharma companies use usable solvents? If not, why are they using undesirable solvents?
Pardon?
Sir, do all the pharmaceutical companies use usable solvents? If not, why are they using undesirable solvents?
Actually, look, the thing is, people are becoming aware, but people are not completely aware. This is difference. So it will take time. If I remember, in last 10 years, we are struggling very high for making people aware. We are delivering lectures. We are taking free workshops to students, to teachers, to industry people, just for making them aware about green chemistry. I am sure out of these 140 odd students or 200 odd students who connected through this webinar, most of them were not aware about the green chemistry principles. So it will take time. But yes, few industry have started, switching from regular practice to green practices. But the world cannot be changed overnight. It will take time.
Thank you, sir.
Any more questions from the students?
Good afternoon, sir.
Yes.
Good afternoon.
Good afternoon, sir. I'm Harini Vasni. I have a question, sir.
Yes.
Please go ahead.
So, how can the green chemistry accommodate the principles of sustainability, sir? Can you explain?
Look, sustainability is inbuilt in green chemistry. When you follow the green chemistry principles, suppose you are using microwave technique.
Yes, sir.
microwave technique comes under the green chemistry. A reaction when you practice through traditional way, it takes 2 days or 3 days. But when you do the same reaction through microwave, it takes only 5 minutes, 7 minutes, right? So
Yes, sir.
then the time reduced tremendously from 3 days to 5 minutes, 7 minutes. So when you reduce time up to that extent, you have reduced energy, you have reduced
And
efforts,
yes,
right? So
yes, sir.
when all you reduce means you are making the environment green, and if you are doing so, you are serving the sustainability issues. So green chemistry practices, green principle practices are all which are helping in the sustainability of environment directly.
Okay,
Direct
sir.
ultrasound and microwave are the techniques which are very less energy consuming techniques, right?
Yes, sir.
And
Thank you, sir.
and, and by using these techniques, you can reduce the energy consumption drastically. So if you are reducing the energy consumption drastically, you are obviously serving the society, you are obviously serving the environment.
Okay, sir. Yes, sir. Thank you, sir. Thank you so much.
All right.
Good evening, sir.
Yes.
Thank you for your wonderful presentation. And we had more
Thank
insights
you.
into history
It is
and
Nimita. Your name is Nimita?
now, Sir Vaishnavi.
Vaishnavi.
Okay, Vaishnavi.
Sir, I have a question.
Yes.
You mentioned about drug recycling, no, sir?
Drug
Recycling. You had a word.
recycling. Yes, yes, yes.
How is that possible, sir, at that
How it efforts? Yes, it is very good question. Drug recycling doesn't mean that we can use one drug for another disease, or we can use one drug in manufacturing in another drug. No. Drug recycling means we can use some drugs, not all, some drugs for the making of fertilizers, for the making of insecticides, right? So that may be used.
Okay.
Another
Yes, sir.
then the drug, the effluent and the waste coming from drug industry may pollute the water resources, may pollute the soil. So when we treat such wastage, when we treat such effluents, we can treat our water, we can treat our soil as well.
Yes, sir.
Treating drug waste or treating water effluent of drug industry is nothing but solving the problem of remediation of soil and water.
Yes, sir. Thank you, sir. That was my doubt, and I had one more doubt, sir.
Yes, yes, please.
In my internship, we used the reduced graphene oxide to treat effluents, sir.
Mhm.
Are there, I don't know if it actually treated the effluent. So, how can we find out that, sir?
Now, effluent of which industry?
Dye industry, sir.
Dye industry.
Yes.
Look, recently, as I shared with you that I have contributed 3 books on dye removal through green chemistry. Actually, dye removal is not the solution. Solution is the breaking of dye molecule.
Yes.
When we break the dye molecule, its coloring property eliminates, right?
Yes.
So by using ultrasound
Yes.
technique, we can break those molecules very easily.
Okay, sir.
And I am sure in your university, some of the researchers were doing this work. If they are using ultrasound technique to remove dyes from water, from effluent,
Yes.
it's good. Otherwise, they must try. You
Sure.
take ultrasound form and just put it in the beaker of dyes effluent,
Yes,
and
sir.
you will see that the color will change. Color become lighter, 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 and suddenly the water becomes transparent.
Yes, sir.
So just because of breaking of
the
big
dice.
dice.
Yes. Thank you, sir. Thank you so much.
Anyone else?
Any other questions from the students? Please feel free to ask. You are there.
Sir,
133.
this is Kirtana.
Yes, first PG, Kirtana.
Yes, ma'am.
Go
Sir,
ahead.
basic doubt, sir.
Yes, yes.
Ask.
Sir, you're speaking about atom economy and it will incorporating it into our studies. It will be very hard. You're telling about it, sir. But
Yes.
changes before changing changes will be made like now we are using equations based on quantity how much steel will be given and to think about atom economy something new, sir. So how far it will be possible and to think in atom economy, how should a person think to have a transition from quantitative to atom economy, sir?
Okay. I got your point. There are two-stage solution. Solution number one, which is at your institution level. Your teachers, your professor must teach you, whenever they are discussing a chemical reaction and discussing on the basis of percentage yield, then at the same time they must discuss the same reaction with percentage atom economy as well, right? So that you can compare these two and understand these two in the same reaction. Number one. Number two, they can introduce green chemistry. They can introduce green chemistry principles in your curriculum, in your syllabus, so that it would be automatically everybody will start learning and doing practice. Okay. The problem is where the problem exists. Problem exists at the policy level. When the education policy, the policy deciding people, when they will introduce percentage atom economy in the syllabus and substitute percentage yield by percentage atom economy, then only the scenario will be changed completely. But as of now, for now, your institute can help you, your teachers can help you, your teachers can educate you, and in future you will be able to change the people, right? So this is an ongoing process, and obviously it will take time.
Yes, sir. Thank you, sir.
Anyone else?
Dr. Amadhaselvi, is there any question in the chat box? You can just read it out.
No, ma'am. No questions in chat box, ma'am.
That's fine. We're happy about the questions that are posed by the students, at least a few questions they have asked.
Yeah.
We'd like to thank Dr. Sharma and I wish to inform you, sir, that right through the last 7 or 8 years of the syllabi of graduate and postgraduate, we have units of green chemistry, and we also have a multidisciplinary course on green chemistry. When we titled it as green chemistry, and it is, since it is a multidisciplinary course offered by the department,
Wonderful.
they were scared to pick this paper as an optional paper in MDC. However, when we changed the title to Green Aspects in Daily Life, we had quite a number choosing the.
Very good.
Even well before, right away from the year 2000, we've been practicing benign methods, solventless synthesis, ultrasound, microwave, and still continuing. Quite a number of organic synthesis has happened. The department also houses a microwave oven, synthesizer actually, and a microwave oven also, as well an homogenizer.
I am sure the future of these students are in very safe hands.
And in units of industrial chemistry, there is for the core subjects we have incorporated green chemistry. But your talk has in fact covered almost quite a big amount of green chemistry and green aspects and sustainability. When they are saving electricity, they are saving the electricity for their future, and that is the same sustainability.
Absolutely,
Students
absolutely.
should understand, and therefore we are very very happy and to have you with us today. And such a nice presentation, sir. You have covered such a vast and in an interesting manner. Now they will be much more understanding what is the green aspect of it. As
Thank
well,
you.
we have had also done quite a number of workshops on micro scale experiments in chemistry. Whatever possible, we have also incorporated in that lab experiments. We never use CCl4. We have never used benzene. Quite from 15 years ago. So we would now you have enlightened us about the new resources and the websites and how we can contribute as a chapter also from our side, and we would like to collaborate with you. Thank you very much.
Definitely, definitely, ma'am. Thank you.
Thank you very much.
Thank you very much.
Over to Dr. Sharada, and my humble pranams to you.
Thank you, ma'am. Thank you, ma'am. Sir, your session was the fitting grand finale to this 2-day national virtual seminar. Thank you for this fantastic intellectual treat.
Thank you
On
very much.
behalf of the department and the institution, I once again thank you, sir, for
Thank you.
taking time out to make this virtual seminar a grand
And in
success.
the interest of the
Thank you,
students,
sir.
particularly, it
Yes.
shows he's a passionate teacher and is much concerned to the career of the students to enlighten them.
And I would be happy to visit anytime
You must be a very
Gujarat
busy
Prince of
person.
University because I visited a few years back. So I found it a wonderful institution. I found it a
Maybe 7 years
Yes,
ago.
sir. So I was here for my PhD candidates, Viva was.
yeah. I came for some PhD viva. Yes.
My candidates, yeah.
Yeah. So I would be happy to visit once again if you kindly invite.
You're
Sure,
welcome, sir. Sure, sir. Sure.
We will definitely.
Thank you very much.
Madam, shall we proceed with the vote of
The
thanks?
collaboration, yes.
Yes. We have now come to the end of the national seminar on Voices of Eminence. It was an enlightening 2 days with valuable insights from eminent academicians. This memorable milestone was achievable by many helping hands. I record my appreciation and gratitude to all the speakers and participants who made this a worthy academic exercise. I now request Dr. Amada Selvi for the formal vote of thanks.
Yes, ma'am. Good evening to one and all. I am happy to propose vote of thanks in this occasion. The Department of Chemistry of Avinash Lingam Institute for Home Science and Higher Education for Women Coimbatore continuously tries to promote awareness in recent development in science, green chemistry and environment in all our activities. This has enhanced both our staff and students from time to time. One such occasion is moving forward right in front of us today, a 2-day national level seminar, Voices of Eminence. Around 175 participants of various departments are taking part in the event. We had delightful discussions on the latest developments on the areas of batteries, importance of medicinal plants, research pathways, and environment sustainability. Sir, we will follow the atom economy in our research work and adopt the green techniques. I'm sure that the participants must have benefited by attending this seminar. At this junction, I express my honest thanks to everyone whose contribution has made this seminar an effective one. I would like to express my sincere gratitude to our higher authorities, Chancellor, Vice Chancellor, our Managing Trustee Anna, Registrar Madam and Dean for providing permission and facilities to conduct the seminar in a systematic way. I thank all speakers for their enthusiastic involvement in this seminar. I am very much thankful to our head of the department, Dr. Subhashini K. Sripati, for her continuous support and guidance which have greatly helped towards the successful organization. I extend a very heartfelt thank to Dr. R. Sharada, Organizing Secretary, for her willingness and involvement to take on the completion of the work. I sincerely thank to all the department faculty members for their valuable suggestions and teamwork. I express my sincere thanks to Dr. Meena, Director, Computer Center, and her team, Mr. Ramesh, for their technical support. Finally, I thank the wonderful students who have turned up in such a great numbers, not only from our department, rather also from other departments of the institutions and other institutions. Thank you so much for your cooperation. Once again, I thank you all your cordial support. Thank you.
Thank you very much.
Thank you, Dr. Amada Selvi.
Yes, ma'am.
Yes, I have a word of thanks for the computer center. In fact, yesterday when Dr. Sharma came onto a trial meet with us and was eager for a live streaming, and we also eagerly told him that we will make it possible by 8 o'clock. 10
No,
o'clock.
I must thank your team. Your team
Yes,
is
sir.
wonderful team. Yeah, it's wonderful
Yes.
team.
And we are very thankful and have express a gratitude to the computer center of our university, Dr. Meena, the manager, and her technical personnel, Mr. Ramesh, for making the live streaming possible. And it was just a surprise for us also. And I hope, Dr. Sharma, you are happy about it.
Yeah. I'm thankful to your team and especially the Ramesh who done a wonderful job.
Yes. We express our thanks to you, sir. That's to you, sir.
Oh, so nice of you. So nice of you.
Thank you very much. Yes.
Thank you.
Thank you, ma'am.
Thank you very much.